Good morning, everyone. My name is Huma Lodhi. I'm working for Direct Line, that is a leading UK insurer. Today I will discuss three things. First, that how deep learning, AI, deep learning, machine learning can provide benefits to insurance. Second, the challenges that insurance data poses and how can we address those challenges. And the third thing is that I will show a few examples of applications of deep learning to insurance problems that can show that will show that there is a business value to do this transformation and to replace existing systems with the new modern deep learning based system. Insurance has a very interesting history. It is as old as human society. But this is interesting to note that this industry has changed according to changes in technology. So as we have seen advances in, as we have witnessed technological advances, insurance has adapted. So the time when there were shapes and people used to do in BC times, there used to be the concept of insurance, but over the years this concept has changed, and now we are in 2019 where we are again witnessing another revolution, and this industry is in the process of transformation. And there are three areas within insurance that can benefit from deep learning AI, and these three areas within insurance are in the process of transformation. So the most important of these areas is risk management. Insurance, the concept of insurance is based on risk diversification, risk pooling. So it's crucial that we correctly diversify risk, we identify the correct segment, and then assign a correct distribution of that risk to that segment. So this is the key idea behind insurance. The other thing is that when we take insurance for home, for cars, for life, and once we have taken this insurance and something unexpected happens, we then contact our insurance company and file a claim. At that time, what we need is that our claims are processed quickly and accurately. So this is the other area, that is the claims management, that is in the process of transformation by the use of machine learning. And third thing is customer. And as Jackson has described, that how customers are important and customers analytics can be improved by the use of machine learning or deep learning. So this is a very important thing. And insurance is different because insurance customers range from millennials to someone who is 97 years old or 99 years old. Someone who is 97 years old can be driving a car, or someone who is 18 years old is driving a car. So a customer who is 18 years old or a customer who is 97 years old can have different preferences, can have different needs. So it's very important that an insurer or insurance company caters need for all of his or her customers. So it's very important. So customers are key for an insurance company. So before discussing deep learning, it's important to see that whether insurance needs this change, and what are the current practices, or how what are the current systems that are in place within insurance industry. Insurance has two types of systems. One is rule-based methods, and these rules can be centuries old. So for example, there can be a rule that has been designed maybe in 1970. Now the rule that has been designed in 1970 cannot be applicable in 2019. So there can be some rules that are relevant today, but there are other rules that are not relevant today. So we have to look at those rules and see what the data says. If the data says the rules are correct, we can have those rules. But if the data says that these rules need to be changed, then there is a need to change those rules. Then the other approach that is common within insurance industry is statistical modeling. In statistical modeling, within insurance industry, a lot of human intervention is applied. So the concept of representation learning that is key for deep learning is done by humans. So insurance is a very human based sector. So all humans spend hours, days, months analyzing data, smoothing. So they do all the representation learning, and all of the human knowledge is incorporated. And once humans have done the representation learning, then a statistical model is learned. Now time is changing, cars are more safe, there are less accidents. So now an insurance company can't have so many humans. It is not cost effective from an insurance perspective to have so many humans who analyze this data. Insurance needs automation. So therefore, in today's world, the current systems are not relevant, they are not cost effective, and they can't provide good customer services. So there is a need that we replace these systems with machine learning, AI based system where we can apply automation. Insurance is data-rich industry. We have data in every form. We have data in databases. For example, when we take insurance, we provide information about ourselves. That is our data. Insurance companies, according to rules and regulations, process this data to compute a right premium for us. Then there are other types of data that insurance companies can have. That is voice data. For example, there is an accident, we phone an insurance company, there is the voice data, then textual data. So insurance is rich in terms of data. And all these different data types have crucial information that is very important to build models and to provide right services. However, as insurance has been a human-centric industry, this data has been analyzed by humans. So for example, if there is textual data, the data has been collected from human perspective. Data is not in a form that is amenable for a machine. It is amenable for a human. So data is not in a form within insurance that can be easily used for machine learning. There are so many data errors. Then data live in silos. And ideally, if we want to build a very accurate, good system, we need to extract information from all these different data sources. So we need somehow a data lake where all the data can be integrated. So these are some of the common issues that are prevalent in within insurance data. Missing values are common, and when missing values are common, there can be two reasons. One, randomness in missing, or there is a systematic missingness. So whenever we are looking insurance data, we have to understand if there are missing values, what does these missing values say? Because missing values also have a meaning. Then there is, as insurance has centuries old industry, there are prior knowledge, there is human knowledge. How can we incorporate that human knowledge within our models? Then how can we integrate different data types? So we have to think about a system that can address all different types of that can address different data issues and integrate different data types. Deep learning can provide a solution to insurance problem, because if we compare deep learning or neural nets to other machine learning algorithms like kernel methods, deep learning or a neural net is, I will say it is simple as compared to kernel methods, but when we used to build kernels, we have to develop functions that were mathematically sound. So machine learning was not as simple as it is now, because now we have software, we can apply machine learning, and machine learning is a mainstream concept. In say 10, 15 years ago, machine learning was not as simple as it is. It was difficult to build algorithms or develop algorithms, and then one has to implement those algorithms, and things were more complex. Now it's very easy to build a neural net. We just need 2-3 concepts. And if we know those 3 concepts, it's like an engineer. We just have to plug those things correctly. And once we have plugged them, we have built a network. And that network is as good sometimes as a human. For example, object recognition, image recognition, we can have by a complex but simple network, we can have a performance that is as good as a human has. So now I will give an example of a deep neural network for risk management. So risk is a key concept in insurance. When we apply for an insurance premium, there are different risks that are associated. For example, when we are going, when we have bought a new car, now we want to have an insurance so that, for example, if something unexpected or something bad happens, we are insured. So, and then when we go to an insurance company has to predict accurately different risks that are associated with a person. Those risks, for example, a risk of fire, an accident can happen, a policy holder can damage another person's car, or his or her own car can be damaged, or there can be injuries. So there are so many risks. So it's very important first that the risk is identified correctly, then risk is diversified correctly. So it means that a group of people who are going to share the risk are identified correctly. We don't want to assign wrong risk to wrong segments. So risk identification and risk diversification is very, very important. And the same applies with home insurance. We have to see whether a particular home or house has flooding risk, fire risk, theft risk. So it's a quite complex process, risk identification and risk diversification. That's why currently insurance systems involve a lot of human intervention. So this is an example of a deep network that shows how we can do risk identification and diversification. There are 3 types of data types that we can have in our data. One is categorical variable, other is numeric variables, and binary variables. Now these 3 different data types have different information. What we have to do is that we want to learn a representation from these data sources and extract all the information that is contained in those different data types. So what we can do is we can start from categorical variables, and through embedding we can learn representation. So within 3 or 4 layers we can learn a representation that contains all the information from categorical variables. Then we can learn a representation from numeric variables. We can learn 3 branches of network where we can learn from numeric, from categorical, and from binary variables. Once we have learned right representation from 3 different data types, we can combine them, and we can apply batch normalization to address covariate shift type of problems. Now when we have learned 3 different representations, we can combine them, and then we can keep on learning representation from the combined representation for next 4 or 5 layers, and we can see a point where we have learned a representation that contains all the information that is required to solve the problem. I'm out of time, so I will be quick now. So once we have learned a representation, we can apply it, and this network can be very good. It can capture information from the data, so it can see that if there is a person who hasn't made any claims for 20 years, his premium should be less than a person who is making frequent claims. So this seems complex, but it is simple, and it can learn it can identify right risk and diversify risk. Similarly, we can handle claims by using deep learning. So for example, in claims, we can have textual and numerical information. We can learn a network. We can learn two networks, one from textual data and other from numeric data. Then we can do, once we have learned two representation, we can combine these two representation and then merge these two representation in one, and then keep on learning till we have learned a representation that is good enough for solving the task at hand. And then in this way we can solve claims problem. And there is a business value. So for example, if we replace our current system with these new systems, we can solve problems quickly. There will be better revenue, better customer services. So these examples show that insurance needs a change, and this change will be useful for customers and for insurance companies. Thanks.